What if I told you the most dangerous thing you do every night isn't eating junk food, smoking, or stress, it's not sleeping? Flushed face because while you scroll one more video, your brain cells are silently dying, your memory is weakening, your hormones are crashing, and your body is entering survival mode. Tonight, we're going inside the human brain in 3D to witness the terrifying truth about what really happens when sleep disappears. Sleep is not rest, sleep is repair. And the moment you stop sleeping, your body starts breaking down faster than most people realize. In this video, we'll explore the shocking 3D science behind sleep deprivation and uncover what happens inside your brain, heart, hormones, memory, and immune system when your body is denied recovery. You'll see how one sleepless night can affect focus, emotions, energy, and even long-term brain health. From microscopic brain damage to dangerous hormonal imbalance, this journey will reveal why sleep is one of the most powerful survival systems ever created inside the human body. Inside your brain, billions of neurons communicate through tiny electrical signals every second. But when sleep disappears, this communication system begins to fail. The brain depends on deep sleep to repair damaged cells, remove toxic waste, and recharge neural connections. Without proper rest, harmful proteins start building up between brain cells, slowing down mental performance and increasing stress inside the nervous system. One of the first areas affected is the prefrontal cortex, the part responsible for decision-making, focus, self-control, and logical thinking. After long hours without sleep, this region becomes less active, making simple tasks feel harder and increasing mistakes, confusion, and poor judgment. At the same time, the amygdala, the emotional center of the brain, becomes overactive, causing stronger emotional reactions, anxiety, anger, and mood swings. Sleep deprivation also reduces the production of important neurotransmitters that help memory, learning, and concentration. Brain cells struggle to transfer information efficiently, which is why tired people often forget names, lose focus, or experience slower reaction times. As exhaustion increases, the brain enters short moments called microsleeps, where parts of the brain briefly shut down for seconds without warning. During healthy sleep, the brain activates a cleaning system known as the glymphatic system, flushing out toxic waste chemicals produced throughout the day. Without sleep, these toxins remain trapped inside the brain tissue, increasing inflammation and cellular stress. Over time, chronic sleep loss can weaken neural connections, damage cognitive performance, and accelerate brain aging. Memory and focus depend on strong communication between different regions of the brain, especially the hippocampus and the prefrontal cortex. When sleep is reduced, these systems begin to lose efficiency almost immediately. The brain struggles to organize information, store new memories, and maintain concentration for long periods. Even after one night of poor sleep, attention span drops, reaction time slows down, and mental clarity becomes weaker. During deep sleep, the brain transfers important information from short-term memory into long-term storage. This process strengthens learning, improves recall, and helps the brain filter useful information from unnecessary details. Without enough sleep, this transfer process becomes disrupted, causing memories to feel incomplete, fragmented, or difficult to access later. People may forget conversations, lose track of tasks, or struggle to absorb new information. Focus also becomes unstable because tired brain cells cannot maintain consistent electrical activity. Neural signals slow down, reducing the brain's ability to process information quickly. Tasks that normally feel simple begin requiring more mental effort. Reading, decision-making, studying, or problem-solving become harder because the brain is operating with reduced energy and slower communication between neurons. Sleep deprivation also increases levels of cortisol, the body's main stress hormone. High cortisol interferes with concentration and makes the brain more sensitive to distractions. At the same time, dopamine balance changes, affecting motivation, alertness, and mental endurance. As exhaustion continues, the brain experiences brief lapses in awareness called attention failures, where focus disappears for seconds without the person realizing it. Hormones are the body's chemical messengers, controlling energy, metabolism, growth, mood, hunger, recovery, and reproduction. Sleep is one of the most important processes that keeps these hormones balanced. The moment sleep becomes irregular or insufficient, the endocrine system begins losing control over multiple biological functions at the same time. One of the first hormones affected is cortisol, commonly known as the stress hormone. Normally, cortisol follows a natural rhythm, rising in the morning to increase alertness and gradually lowering at night to allow the body to rest. When sleep is reduced, cortisol levels remain elevated for longer periods, keeping the body in a constant state of stress and alertness. This increases anxiety, irritability, muscle tension, and mental exhaustion while also placing extra pressure on the heart and nervous system. Sleep deprivation also disrupts insulin regulation. Insulin helps move sugar from the bloodstream into cells for energy. Without enough sleep, cells become less sensitive to insulin, causing blood sugar levels to rise. The body then struggles to control glucose efficiently, increasing fatigue, cravings, and the long-term risk of metabolic disorders. At the same time, hunger hormones become unstable. Levels of ghrelin, the hormone that stimulates hunger, increase significantly, while leptin, the hormone responsible for signaling fullness, decreases. This imbalance causes stronger cravings for high-calorie foods, sugar, and processed carbohydrates. The brain starts demanding fast energy sources because exhaustion forces the body into survival mode. Growth hormone production is also heavily linked to deep sleep. This hormone is essential for muscle repair, tissue recovery, cell regeneration, and physical healing. When deep sleep is interrupted, recovery slows down, muscles repair less efficiently, and the body experiences increased physical fatigue. Athletes, students, and workers all experience reduced performance because the body cannot fully restore itself overnight. In men, testosterone production drops when sleep duration decreases. Testosterone supports muscle strength, motivation, energy levels, reproductive health, and mental drive. Low sleep can reduce testosterone production significantly, leading to lower energy, poor recovery, reduced concentration, and mood instability. In women, sleep disruption can interfere with reproductive hormones, emotional regulation. In menstrual balance, the thyroid system can also become affected, slowing metabolism and reducing the body's ability to regulate temperature, energy production, and overall physical performance. As hormonal imbalance spreads through the body, multiple organs begin working under higher stress with reduced efficiency. The immune system is the body's internal defense network, constantly working to detect and destroy viruses, bacteria, harmful cells, and infections before they spread. Sleep plays a critical role in keeping this defense system active, organized, and efficient. During deep sleep, the body increases the production of protective immune cells and releases important proteins called cytokines, which help fight inflammation, infection, and physical stress. Without enough sleep, this entire protective process begins to weaken. After even a single night of sleep deprivation, immune activity starts to decline. Natural killer cells, one of the body's fastest immune defenders against viruses and abnormal cells, become less effective. These cells normally identify and destroy infected or damaged cells before they multiply. Reduced sleep lowers their activity, making the body slower to respond to illness and increasing vulnerability to infections. White blood cells also struggle to coordinate properly during prolonged exhaustion. Communication between immune cells becomes weaker, reducing the speed and accuracy of immune responses. The body may take longer to recognize invading pathogens, which allows viruses and bacteria more time to spread inside tissues and organs. This is why people who sleep poorly often become sick more frequently or recover more slowly from common illnesses like colds, flu, or infections. Sleep deprivation also increases inflammation throughout the body. Normally, inflammation is a controlled response used to heal injuries and fight harmful organisms. But without proper sleep, inflammatory chemicals remain elevated for extended periods, placing stress on blood vessels, organs, joints, and tissues. Chronic inflammation has been linked to weakened organ function, fatigue, body aches, and increased strain on the cardiovascular system. Stress hormones like cortisol also play a major role in suppressing immune performance. When cortisol stays elevated due to lack of sleep, the immune system shifts into a weaker defensive state. The body begins prioritizing survival and alertness instead of repair and recovery. Over time, this constant stress response can reduce the production of protective antibodies and weaken the body's ability to build long-term immune resistance. Deep sleep is also essential for cellular repair and tissue regeneration. While sleeping, the body repairs microscopic damage caused by physical activity, stress, toxins, and daily wear on cells. Without enough recovery time, damaged tissues heal more slowly, and the body accumulates higher levels of internal stress and oxidative damage. Cuts, muscle soreness, inflammation, and illness recovery all become slower because the body cannot fully activate its repair systems. The gut microbiome, which plays a major role in immunity, is also affected by poor sleep. Trillions of beneficial bacteria inside the digestive system help regulate immune responses and protect against harmful organisms. Sleep disruption can alter the balance of these bacteria, weakening digestive health and reducing immune efficiency throughout the body. As sleep deprivation continues for days or weeks, the immune system becomes increasingly unstable, forcing the body to operate with reduced protection, slower healing, and higher physical stress across multiple organs and biological systems. The heart and the entire cardiovascular system are deeply connected to sleep, relying on it as a reset phase where blood pressure stabilizes, heart rate slows, and vascular inflammation is reduced. During healthy sleep cycles, the heart enters a natural recovery rhythm, giving arteries and blood vessels time to relax and repair the daily stress caused by movement, emotions, and metabolic activity. When sleep is consistently reduced or completely absent, this recovery process is interrupted, forcing the cardiovascular system to operate under continuous pressure without proper rest. One of the earliest effects of sleep deprivation is an increase in blood pressure. Normally, blood pressure dips during sleep, allowing the heart to reduce its workload. Without this nightly dip, blood vessels remain in a semi-constricted state, keeping pressure levels elevated for longer periods. This constant strain forces the heart to pump harder against resistance, increasing overall cardiovascular stress. At the same time, heart rate variability becomes unstable. Heart rate variability is the natural variation in time between heartbeats, and it reflects how well the body can adapt to stress. Poor sleep reduces this flexibility, making the heart rhythm more rigid and less responsive. This reduction in adaptability is linked to higher levels of fatigue, stress sensitivity, and reduced cardiovascular efficiency. Sleep deprivation also triggers the release of stress hormones such as cortisol and adrenaline. These hormones prepare the body for fight or flight responses, increasing heart rate and tightening blood vessels. While this response is useful in short-term danger situations, prolonged elevation due to lack of sleep places unnecessary strain on the heart and arteries, increasing wear and tear over time. Inflammation inside the blood vessels also increases when sleep is reduced. The inner lining of arteries, known as the endothelium, becomes more stressed and less efficient at regulating blood flow. This can lead to stiffness in the arteries, reduced elasticity, and impaired circulation. Over time, this creates an environment where cardiovascular diseases are more likely to develop. Sleep deprivation also affects cholesterol balance. The body struggles to maintain healthy lipid levels when rest is insufficient, often increasing LDL cholesterol while reducing HDL cholesterol. This imbalance contributes to the buildup of fatty deposits inside blood vessels, gradually narrowing them and increasing the risk of reduced blood flow. Another major effect is the increase in resting heart workload. Even during periods of inactivity, the heart continues to operate at a higher baseline level than normal. This constant overactivation reduces long-term efficiency and increases the risk of irregular heart rhythms. The heart is essentially forced to operate without its essential recovery window, leading to cumulative stress over time. Sleep loss also affects blood clotting mechanisms. The balance between clot formation and clot breakdown becomes disrupted, increasing the risk of abnormal clot development inside blood vessels. This creates additional strain on circulation and can interfere with smooth blood flow throughout the body. Even oxygen delivery efficiency can be impacted indirectly. When the cardiovascular system is under stress, the distribution of oxygen-rich blood to tissues becomes less efficient, contributing to fatigue, reduced physical performance, and slower recovery from physical exertion over extended periods. Chronic sleep deprivation places the heart in a continuous state of strain, affecting pressure regulation, vascular health, hormonal balance, and circulatory efficiency simultaneously, creating a cascading effect across the entire cardiovascular system. Emotional and mental stability depend on a delicate balance between brain chemistry, neural communication, and hormonal regulation, all of which are heavily influenced by sleep. When the body is well rested, emotional responses are processed calmly, thoughts are organized clearly, and stress is managed effectively. When sleep is removed, this balance collapses and the brain enters a heightened state of instability that affects mood, behavior, and psychological resilience. One of the first changes happens in the amygdala, the part of the brain responsible for processing fear, anger, and emotional reactions. Without sufficient sleep, the amygdala becomes hyperactive, reacting more intensely to even minor stressors. Situations that would normally feel manageable can suddenly feel overwhelming, leading to increased irritability, frustration, and emotional sensitivity. At the same time, the connection between the amygdala and the prefrontal cortex weakens, reducing the brain's ability to regulate emotional impulses and apply rational thinking before reacting. This disruption creates a state where emotions take control faster than logic can intervene. Small misunderstandings can escalate into strong emotional reactions, and the ability to remain calm under pressure becomes significantly reduced. Emotional resilience weakens, making it harder for the mind to recover from stress or disappointment. Sleep deprivation also affects neurotransmitters such as serotonin and dopamine, which are responsible for mood stability, motivation, pleasure, and emotional satisfaction. When these chemicals become unbalanced, feelings of sadness, emptiness, or lack of motivation can increase. Activities that normally feel enjoyable may lose their emotional reward, contributing to a sense of mental fatigue and reduced interest in daily life. At the same time, cortisol levels remain elevated, keeping the brain in a constant state of stress alertness. This prolonged stress response prevents emotional recovery and increases feelings of anxiety, restlessness, and mental exhaustion. The mind becomes trapped in a cycle where stress prevents rest, and lack of rest increases stress. Sleep deprivation also impacts cognitive flexibility, the brain's ability to adapt thinking patterns and shift perspectives. This reduction makes problem solving more difficult and increases negative thinking patterns. The mind becomes more rigid, focusing on problems rather than solutions, and small challenges can feel disproportionately large. Decision-making ability is also strongly affected. With reduced sleep, The brain relies more on emotional reactions rather than logical analysis. This leads to impulsive decisions, poor judgment, and difficulty evaluating consequences clearly. The ability to think long-term becomes weakened, and short-term emotional responses dominate behavior. Memory of emotional experiences is also altered. Negative emotions tend to be stored more strongly when sleep is lacking, while positive emotional memories are processed less effectively. This creates an imbalance where negative experiences feel more dominant, influencing overall mood perception. Social behavior is also impacted. Reduced sleep lowers patience, empathy, and tolerance, making interactions with others more challenging. Miscommunication becomes more likely, and emotional misunderstandings increase due to reduced ability to interpret tone, facial expressions, and social cues accurately. In extreme cases of prolonged sleep deprivation, the brain can begin to experience micro-disruptions in perception, where thoughts become disorganized and emotional stability becomes significantly impaired. Anxiety levels can increase, and the mind may feel constantly overstimulated without the ability to fully relax or reset. Over time, continued lack of sleep creates a cycle where emotional regulation becomes weaker, stress becomes stronger, and mental resilience declines, affecting every aspect of psychological well-being, from daily mood stability to long-term mental health balance.